Okay, so this was what we had done. In the last class, we had done such questions of work and energy, where we observed that the work is equal to the change of kinetic energy. Basically, our formulas, they involved that the work is equal to the change of kinetic energy. This was the relationship that we obtained in the last class. Okay, so just giving a quick revision of all the things which are there in this chapter. First of all, in this chapter, you have about the formula of work done. So the formula of work done is F into S, force times displacement. Okay. Then you have some concepts regarding positive work. Work can be positive, or it can be negative, or it can be zero work. Okay. So for the zero work done, you have certain cases where it can be zero if the angle is zero. So then also the work done will be zero,
90
right?
degrees.
90 degrees. Okay. So this was one thing. Then you have the SI unit of work done. What was the SI unit of work? SI unit of work was Joule, right? So Joule was the SI unit of work. Then Joule is also equivalent to Newton meter. Right? So this was all we had done about the work. Then we had done something about potential energy. And in that, basically, we had done about gravitational potential energy. We had also done about the different other forms of the potential energy, but we had seen the measurement of the gravitational potential energy, which is given by mgh. So the gravitational potential energy is given by mgh, right? Also, it is independent of the path followed. By what path the work is being done, that is independent of it. Okay. Then the third one, we did about the kinetic energy. And the formula of kinetic energy was equivalent to 1 by 2 mv squared, where m is the mass of the particle and v is the velocity, right? So it's 1 by 2 mv squared, that is the kinetic energy. Then we did about our work done, the relationship between work done and kinetic energy, that we also call as the work energy theorem. So as per the work energy theorem, the work done is equal to the change of kinetic energy. That is, work done is equal to 1 by 2 mv squared minus 1 by 2 mu squared. Right? That is the work energy theorem. Work done will be equal to change of kinetic energy. Right? So any doubts in any of these points?
No, sir.
Okay. The last one we also have done about the transformation of energy. Transformation of energy, where we observe that the energy can be changed from one form to the other. It never gets destroyed. You cannot destroy energy. There is just a conversion of one form of energy to the other form. And we will see one of the forms of the one of the transformation of the energy. Everyone turn on your camera. Pranaya, Aman, right? Everyone turn on the camera. Okay. So in the transformation of energy, as I gave you some of the examples of the conversion of chemical energy, I gave you 8 names: chemical energy, electrical energy, light energy, heat energy, sound energy. These are the different forms of energy in which energy exists, and it always gets transformed from one form to the other. We will see one such transformation where there is transformation only into two forms of energies. Okay. So in that way, you observe a pendulum and a roller coaster. So we will observe two things. We will observe a pendulum, what happens with the pendulum, and what happens with a roller coaster. So in the case of pendulum, it is a mass tied to a thread. So a heavy point mass tied to a thread is called as a pendulum. It is fixed at one of the points and it is allowed to rotate about this point. So let's say it has the extreme positions which have been marked over here, and it can rotate about these 2 points. So the 2 points, they are the extreme points, and this one is the mean point. So A, B, and O. Right? So how do we observe its motion? Then we will talk of the energy that is occurring. So energy changes that are occurring, we will see what are the energy changes that occur in the motion of the pendulum. So let this be the mean level. So that is why we call this as the mean position. So this one is the mean position, and A and B, they are called as the extreme position. So this you can see, this is the extreme right position, this is the extreme left position of the pendulum. Both are the extreme positions. Now, when I take the pendulum to this position A, I take the pendulum to the position A and release the pendulum from here. So its speed increases. As it moves towards the point O, its speed increases slowly. And when it reaches the point O, it has the maximum speed. When it reaches the point O, it has the maximum speed. After this point O, it again starts moving towards the point B and its speed starts decreasing. When it starts moving towards the point B, its speed starts decreasing. Okay. So during its motion from A to O, its speed is increasing, and from O to B, its speed again decreases. And when it reaches the point B, the extreme position, again its speed becomes zero. So at these positions, you will have its velocity equal to zero. Both at A and B, its velocity will be zero, but at the mean position, it will have a maximum velocity. Okay. Anywhere in between, it will have some velocity also. Anywhere, if you can see, so here it will have some amount of velocity. Plus, you can observe that it is at a certain height from the mean level. Two extreme position, at the two extreme positions, the bob is at a certain height from the mean position. As you can observe, there is a difference of height between the mean position and the extreme positions, right? So if we talk now in terms of energies, so when the bob is at the position A, we can see that there is a change of position. There is a net displacement along the gravity, right? So it has displaced through a height h. So can I say that at this point A, the bob has potential energy? Right? Prince, can I say that at the point A, the bob will have potential energy only?
Yes, sir.
Okay. What will be the kinetic energy at this point? Yeah, Chavan, what will be the kinetic energy at the point A?
Sir, I don't know.
Don't know. Okay, what was the formula of
Zero,
kinetic
right?
energy?
I think it's zero. Half mv squared.
Okay.
Velocity is zero, so everything has to be zero.
Yeah,
I guess.
velocity is zero. So at the extreme position A, we have some amount of potential energy which is non-zero, but at this point A, its kinetic energy will be equal
And
to
just
zero. Okay.
okay.
When it is coming down to the position A, so when it comes down to the position A, it is gaining speed but losing its height. Okay. Since potential energy was given by mgh, so it was at a certain height h. It had potential energy. Now when it is at this point O, so it has lost all the height, right? Its height is zero now. Now can we say that the height of the bob is zero? Okay. So its height is zero. At this position, it should not possess any potential energy. So at this point, its potential energy will be equal to zero, right? The
Sir,
potential energy, yes.
but it's still at a height, like when we look at it from the ground level, it's still at a height, right? How will
Mhm.
its potential energy be zero?
See, the potential energy, if you talk of really, so in reality, potential energy is never zero. Okay. Potential energy is always measured with a reference. Okay. So with at every point it will have some potential energy. Even at the surface also its potential energy will not be zero. Potential energy is always measured as a difference, right? So that is the reason we have chosen this point to be the reference point. So we choose this height to be the reference height, right?
Yes, sir.
Okay. So this is the reference point, and from the reference point it had attained a height h. We took the ball from this point H. We did not took it from the ground and released up to this point. Did we?
No, sir.
No. So that is why we are looking only for the reference point, right?
Yes, sir.
In
Got
higher
it.
classes, in your grade 11, you will see that potential energy is always measured as a difference and it's not absolute. Okay. Absolute potential energy will be zero only at infinity. So that is why that is why just we consider this at this point its height will be zero since we started from this point only. So what will be the change of potential energy? It will be zero. Suppose even if it was at a certain height from the ground, let's say this is the ground, so it was at a certain height h from the ground, right? Okay. So it had some potential energy at this point as mgh. But what was the potential energy at this point then? Then at this point, it has its potential energy as
That's
mgh plus h.
yes, sir.
Okay. So again, when it comes, it will have its same potential energy mgh. So no need of this having mgh every time. We can choose the reference to be this point and we can say that yes, at this point, it will have its zero potential energy. Right?
Yes, sir. Got it.
Okay. So now when it again starts moving from the mean position towards the other position B, its speed decreases. And when it reaches the point B, its speed is zero. So now it has at this point B, its kinetic energy is zero. The kinetic energy is equal to zero, right? But it has some amount of potential energy which will be equal to mgh since it will reach the same height h, so it will have the same potential energy. Okay, so we observe here clearly that there is just a change of energy from one form to the other. The energy is changing from potential to kinetic, kinetic to potential. Again, it will come from B towards A, towards the mean position. So on, it will go on moving. And in this scene, we observe that there is just a change of kinetic energy to potential and potential to kinetic. Is this clear to everyone? Okay. So, but in real life, in reality, if we see in this way, the pendulum will keep on moving, right? It will keep on moving. It will never stop. Yeah, the pendulum shall never stop in this way. Okay. So why does a pendulum stop there?
It runs out of energy, but I don't know how.
Yeah.
It runs out of energy.
Yeah, it runs out of energy. It's actually running out of energy. But how? That's because of resistive forces of air. Okay. Due to the
Oh,
resistive
every
forces of
time
air.
it. Oh, okay. Every time it makes it like slow down a bit.
Yeah, the air makes it slow down every time. So every time it's losing some amount of energy. That is why the pendulum is coming to a stop. Okay. So that energy is when air is trying to stop it, its energy is getting converted to heat energy. Now the similar thing, can you explain about the roller coaster? A roller coaster. I hope you have seen something like this.
So,
Can you explain? Yes.
I wanted to explain that.
Yeah, try it out. I'm marking it at different positions. So what can you say about these positions?
So first, like the first dot, it's like at the minimum height. So there, the potential energy must be like zero,
Yeah.
as like height is very less, and as we move up, like the kinetic energy starts decreasing. At the first point, the kinetic energy is max,
Mhm.
but as the velocity increases and the height increases, no,
When, okay, let's say this be point A, point B, point C, D, E. So what form of energy will be available at B?
at B, no, wait. Yeah, potential energy will be there because height is
Okay.
max.
So at B, it will have potential energy. What will be at C?
Kinetic energy, velocity increases and height decreases.
Okay, so at this point, it will have the kinetic energy. At the point D,
Potential.
yeah, it should have here potential plus kinetic both, right?
Yes, sir.
But maybe because of if there is any loss of energy, so maybe some energy may be remaining, or maybe some all of the kinetic have been lost. And at this point, it will have only the kinetic energy. Okay, so everyone understood this conversion of energy. Okay. Now let's see the next concept we have done already about power. Let's see some questions now. Okay. Any doubts up to here? Anyone? Siddharth?
No, sir.
Okay. Siddhisri, any doubts? See, for the complete revision, I have written here all the formulas. You can check. All the formulas which are involved in this chapter, you can check. The work done, potential energy, kinetic energy, work energy theorem, transformation of energy. Okay. So these were the formulas. Now the only thing we have not written here is the work and formula of power. So we can include that also. Power is equal to rate of doing work by time. Work by time, and its SI unit is what? Okay, let's see some questions.
Hello, sir.
Yeah,
Hmm.
yeah. What happened?
Sir, what are you opening?
I'm opening the questions. See, let's see. A person holds a bundle of hay over his head for 30 minutes and gets tired. So has he done some work or not? And justify your answer.
No.
No, he hasn't done any work.
Yes, sir.
So why is he getting tired?
Mm.
You have to explain that also. Why is he getting tired? See, he has not done any work on the bundle, but his muscles are continuously working to lift the bundle on his head. Right? So that is why he gets tired. Work is done on his muscles. Okay. So he is getting tired because of his work done by his muscles on his body only. Then next one, see question number 14. Try to compute question number 14. An electric heater is rated 1500 watt. How much energy does it use in 10 hours? So how much energy does it use in 10 hours? Okay, Chavan Kaushik, which formula is to be utilized?
For the which
Uh,
question, sir? 13th.
Question number 14. I'm talking question number 14. Electric heater is rated 1500 watt. How much
MGH.
mgh? Mgh. Smith, what formula shall we utilize here? We want to find out the energy consumed by the electric heater.
Sir, power is equal to energy consumed.
Sir, wait, no.
Yeah, Smith, your
Sir, kinetic energy or just energy? Sir, is it kinetic energy or just energy? Sir, I think it's half mv squared. Sir, can you hear me?
I think there was a network error from my side.
Sir, is it half mv squared?
No, no half mv square. Where is mass? Where is speed? Do you have anywhere mass and speed?
No.
No, then
15,000 watts.
how much?
15,000 watts or 15 kilowatt per hour.
No, you have to compute the energy and power is given, time is given.
Yes, sir. So 1500 into 10 because 10 hours is given and power is equals to work divided by time.
Okay, so is hours the SI unit?
We need to find in kilowatt per hour.
Kilowatt per hour or kilowatt hour?
Hour.
Yeah. So either you can use kilowatt hour or you can use joule. So if you want to use joule, in that case you have to convert your hour into second. Okay. So Chavan, can you show your answer?
Sir, I'm not sure. How much is it?
Okay. If you're not sure how, whatever you have done, just show that.
No, I was planning on using half mv squared, but I cannot use it. I didn't get this one.
Yeah. Just see the reference. What the question is talking. Okay. So first of all, from the question, take out the values which are given. So here you are given about the power. The power is given as 1500 watt. Okay. Then you are given the time. The time is 10 hours. Okay. So of course we will use the formula of we need to compute here energy. So we can use the formula power is equal to energy by time. Okay. And therefore energy from this expression we can get energy equal to power into time. Yeah, Siddhisri is Siddhisri.
Yes, sir.
Okay. So are we doing it correct?
Yes, sir.
Okay. So what changes do we need to make before we put the values? Are there any changes which we need to make before we inject the values?
Sir, convert it into kilowatt or joule.
Yeah. See, we have for the unit of energy, we can either use joule or we can use kilowatt hour, right? If we want to use joule, so we need to convert this hour to second. We want everything in the SI unit. Okay. Since joule is the SI unit, so everything should be in the SI unit. We observe that what is already in SI unit. So we can write here 1500. It's already in SI. Multiplied time, it is 10 hour. So 10 hour to be converted to second. Okay. 1 hour will be equal to 3600 and therefore 10 hours will be multiplied by 10. Okay. So this will be the amount of energy in joule. You need to multiply 15 and 36 and the remaining all will be zeros which is 10 to the power 5. So multiply all this, you will get your answer in joule. The same thing if you want your answer in kilowatt hour. So in that case, you need to convert this 1500 watt to kilowatt. Okay. So how we will convert this to kilowatt? Siddhisri? Yeah, Siddhisri, how can we convert it to kilowatt? Or Smith, how we will convert this to kilowatt?
Divide by 1000.
Divide by 1000, right? 1500 divided by 1000 will be in kilowatt. Okay, so it will be 1.5 kilowatt. And then you can directly use this formula. In that case, you convert this watt to kilowatt, that will be 1.5 kilowatt multiplied by time, that's hour. Take the time in hour only. So you will get your answer as 15 kilowatt hour. That is the simple answer that you. Or Smith understood this problem?
Yes, sir.
Okay. And Siddhisri, what about you? Siddhisri, did you get the answer? Pranaya?
No, sir.
Okay, Siddhisri, you didn't get. So which method did you not get? The first one or the second one?
First one.
The first one. See, in the first one, everything is to be used in the SI unit. Okay. So the formula of energy is power into time. Power is 1500. And what is its unit? So what is the SI unit? So we can put directly the value 1500 without any conversion. Okay. Time is given as 10 hour. So 1 hour has 3600 seconds. So therefore 10 hour will have 10 into 3600. So that is what has been written. Then you multiply all of them. This is your answer in joule and this is your answer in kilowatt. Okay. So let's practice some more questions. Apart from the NCRT, now I'll be giving you some more questions there. Just wait for 1 minute. I'm giving you some more questions. Just wait for 1 minute. Wait. Wait. Okay, fine. I have the questions now. See. Okay, so this is from work, energy, and power. You have the complete revision, and then we can start with the questions. See. So first question, does work done depend upon the velocity of the body? So whoever knows the answer, all of you can unmute yourself. All of you unmute yourself, and whoever knows the answer can answer the question quickly. Okay, so no foundation for anyone. All of you unmute your answers. Unmute yourself and see if you know the answer. Answers are already given here, but still try your own sense. Okay, so first question is, does work done depend upon the velocity of the body? Does the work done depend on velocity? The answer is no. Work done depends on force and displacement. That are the two things. From the formula, we have work done equal to force into displacement. So work done depends only on force and displacement and not on velocity. The second one, state the law of conservation of energy. So according to the law of conservation of energy, we have observed that the law of conservation of energy states that the energy can just change from one form to the other and it can neither be destroyed nor be created. Then, in a tug of war, one team gives way to the other. What work is being done, and by whom? So, who is doing the work over here? Tug of war means where two teams are pulling a rope from two sides. Okay. So, is there any work done? So the answer is that the work will be done or the displacement will be achieved only by the team which is the winner. The losing team will not be able to displace the rope. Okay. So therefore, work is done by the winner team. See here, find the energy in kilowatt hour consumed in 10 hours by a machine of power 500 watt. Okay. So however, the answer is in front of you, but try to solve this. Solve this question. Find the energy in kilowatt hour consumed in 10 hours by a machine of power 500 watt. Okay. Who else has got the answer? You have to find the energy in kilowatt hour. Who all have got the answers?
Sir, I got 5.
Okay. Anyone else? Aman?
Sir, I got 5.
Okay. I think Siddhisri is here. Siddhisri, did you get the answer? Do not see their solution. Try your own solution. And if you're not able to get it, then tell me. Hmm. Okay. So, Siddhisri, what about you? Have you got the answer?
What?
Yeah, have you got the answer?
Sir, I'm doing so.
You are doing. If you are still doing, see, I told you a simple method. Convert watt to kilowatt and use your time in hour. So how many watt are here? Siddhisri, how many watt are given? Yes, Siddhisri, how many watt? It's 500 watt. So convert this 500 watt to kilowatt. Okay, see, let's see some of the questions which are unsolved. Okay, see. Uh, I need to do some of the long questions then. Okay. See here, question number 2. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side. So now this time Siddharth will explain. Yeah, Siddharth.
Can you repeat the question?
It's your question number 2.
When the pendulum bob is pulled towards the
Hmm.
extreme, then the potential energy is zero, and when we leave it when it's at the mean position, the then the
I guess
energy of the potential energy of the bulb will be at the max, and when it's at the other end, then it will be at
I think you are
zero.
getting confused between potential and kinetic. Which will be zero and which will be maximum. Think of it 1 minute and then start speaking. Okay. So just I realized that once I turned on the off the camera because of some of the eye problem. So that's why I saw all the cameras off. Aman's camera is off, CTC camera off, everyone's. Okay. Uh, Siddhisri, can you explain this question? Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Yeah, Siddhisri, did you get the answer? Uh, I don't think she's not able to respond. I think. Okay, not here. No issues. Okay, let's see. Some long questions then. Five marks questions. So I give you this 5 marks question. We will solve this, but in the beginning 5 minutes, you are supposed to do this question. So this question you are supposed to do in the beginning. For beginning 5 minutes, I'm allotting it to you. Let's see if you are able to do this. Okay. Or the person who is able to do all the parts. And do keep in mind, when you have to find out the cost of energy, you have to use, in this case, you have to use your energy unit as kilowatt hour only, which is the commercial unit. So you have to use commercial unit, which is also called as unit. So kilowatt hour is also called as 1 unit. 1 kilowatt hour is equal to 1 unit. Okay. So I'll provide all the necessary explanation after 5 minutes. Just not 5 minutes. I'm giving you 2 to 3 minutes. Let's see whoever is able to do this question. Okay. So who has got the answer? All those who have got the answer, they can send their answer in the chat section. In the chat section, I want to see the answers.
Sir,
If
can you
anyone
give
has,
me 1 more minute? One more.
yeah. Okay. Okay. Fine. Okay. See who all have obtained.
Sir,
Yes.
so like what we are supposed to do here is first like multiply the time with the amount of items and then with the like power and then turn it into
Okay.
kilowatts, right?
Okay. There is just one hint. First of all, find out the energy consumed. You need to find out the energy consumed by each device. So energy consumed by 3 bulbs, okay, in 31 days. That you need to compute. Then you need to compute the second thing as energy consumed by 4 tube lights by 4 tube lights, again in 31 days. Then the last one you need to compute is the energy consumed by TV. Energy by TV in 31 days. Then add up all the energies. All the energies need to be found out in kilowatt hour only. You need to find all in kilowatt hour. Then add up all the energy to obtain the total energy. Okay. Once you obtain the total energy, then multiply that energy by the rate given, which is 2.50. Okay. So your times are over. Still, if you are able to do, I think, okay, Chavan Kaushik has sent some of the answers and he has sent the last answer also. And no one else. Orosmith, you didn't get?
Yes, sir.
Okay, see. You have three bulb of 40 watt each. So power of three bulb will be 3 into 40 multiply by 6 hours and multiply by 31 days. But this has to be taken in kilowatt. So therefore divided by 1000. Okay. So this is the energy consumed by the three bulbs. In the similar way, you need to compute the energy consumed by 4 tube lights and power of one tube light is 50 watt. Okay. So 4 times of 50 divided by 1000, that will be the power in kilowatt, multiply by time, which will be 8 into 31. In one day it runs for 8 hours. So in 31 days, it will run for 8 into 31 hours. Okay. The last one, energy consumed by the TV, again in the same way, it will be 120 and there is only one, so 120 multiply 1, divide by 1000 and multiply by the time. The time here is 6 hours. So 6 into 31. Okay. So for the first one, if you multiply, you get 6 into 31 into 3 into 40 divided by 1000. So this will be 22.3 kilowatt hour.
So isn't it 2 to 3.2?
No, it's divided by 1000. So it will be 22.3 kilowatt hour. The second one is the second one is 4 into 50 into 8 into 31.
49.6.
Okay. So I think now you can compute this answer. Okay. At the end, you have to add up all the energies and multiply by 2.50. Okay. So bye everyone. Good night. We'll see again tomorrow.
Bye, sir.
Okay.